today we're going to be integrating ln of 1 plus sine x over 1 minus sine x between 0 and pi over 2. So the first thing we're going to do is we're going to use King's rule. We can say u equals pi over 2 minus x, which gives us du equals minus dx. Now, with King's rule, our limits end up staying the same. However, instead of sine x, we're going to write sine of pi over 2 minus x. And this actually is just cosine of x. So 1 plus cosine x, 1 minus, well, that should be cosine x as well, dx. And this is the same integral as above. So with this, we can do some trig manipulation. We can say cosine x equals 2 cos squared x over 2 minus 1. And putting this into our integral, we'll get ln, and then on the top we'll just have 2 cosine squared x over 2. On the bottom we'll have 2 and then 1 minus cos squared x over 2. And we can see we can actually just write this as sine squared x over 2 on the bottom. And as such, just simplifying that, we'll get cotangent squared x over 2. Okay, we can use the log law where we can sort of bring the power out and reciprocate it. So we get minus 2 at the front, and we'll have ln of tangent x over 2 dx. And if we say u equals x over 2, we get du equals a half dx. And now our integral becomes minus 4 on the outside, 0 to pi over 4 ln of tan u du. And this might be looking quite familiar. If we do another substitution, let's say v equals tan u, dv equals sec squared u du, and we have the following integral, 0 to 1 ln of v 1 plus v squared dv. And this is actually just equal to minus g. If you've seen my video, the I plus j method, that goes into quite a bit of detail on how that sort of works, but I'll quickly describe it here. So essentially, because we're integrating between 0 and 1, we can write the denominator as a power series. So that's going to be minus 1 to the n times x to the 2n, but we can keep the x to the 2n inside of the integral, and we end up with ln x times x to the 2n. And you can see I've just replaced v with x, as it doesn't really matter. So here we can do that integral on the right using parts. So we end up with the series times, what do we have? We have ln x times x to the 2n plus 1 over 2n plus 1. And that's between 0 and 1. And this actually just is 0. And we subtract 1 over 2n plus 1, and integral of x to the 2n dx. So we can now write this as minus 1 to the n over 2n plus 1 squared, which is minus Catalan's constant, which gives us our answer as 4g.